Hello all, this is John from EastCoastArmory.com, and I'm here today with a project update video for this 1/6 scale Armortek Radio Control Early Production Panther Ausf.G. Since the last video, a lot of progress has been made to the model's mechanics as well as the model's interior. If you watch closely in my other video, during the first test drive, the model had an issue with the rear wheel here in the back. The rear wheel in the back kept on pulling upward when only this track would be driven. The reasons for that were actually made up of a bunch of reasons. First reason was the bump stops as well as the pin deflector were snagging the track. When they were snagging the track, they were adding more tension to the track than designed, and the wheel gave a bit. Also, the track's tension was the track was a lot looser because there was about 2 or 4 too many links that were on the belt. Once the links were shortened, the track, as you can see now, it's a lot more uniform and thus won't kink when the model is driving. Another reason why the wheel was going up was also because of the track tension. That was because of the rear idler wheels weren't really set and adjusted right. Once those were adjusted, that was another issue that prevents the track from kinking. But more importantly, the one reason why the wheel was snagging up was because of a mechanical issue with the battery tray. The way the previous model builder mounted the battery tray was inhibiting the torsion bar from properly swinging. The previous builder, when he mounted the battery tray, he mounted it too close to the torsion bar, and the tray itself was actually hugging the bar. Because it was hugging the bar, the spring tension that is normally found in the steel rod was not being used, because instead of the torsion being performed over here at this end, it was being performed over here at this end, which reduced the springing power of the steel bar. Because of that, and with the addition of all the other issues that I mentioned earlier, caused the wheel to spring upward prematurely when the model would be driving. Once all of these features were addressed and fixed, the model was on a second test drive and had absolutely no problems with the wheel lifting up as it did in the earlier test drive footage. In addition of the track tension being off, another reason why the model was skipping and jumping a bit during the first test drive was because there were some obstacles that the track was hitting that are on the side of the model's hull. These obstacles would include some of the actual detailing, namely the rubber bump stops as well as the small pin deflector. Small mods had to have been made to these locations so that the track would roll smoothly over them in opposed to constantly whacking them as the track goes by. Here goes the one bump stop here to show the modification that was made to it. As I zoom in, as you can see, the bump stop here had to have been grounded off quite a bit so that it's nice and free from any obstruction that could possibly hit the track. This was done via the Black & Decker Power File, which is a long, skinny mini belt sander that has a nice thin little belt that can easily get in there, especially before the track was mounted, to sand away the unneeded material. After the position was sanded down, the one bolt that's used to hold the top portion of the bump stop to the hull fell off. Instead of positioning another hex bolt on, I countersunk the actual piece here and replaced the hex bolt with that of a countersunk Allen screw. The countersunk Allen screw gives more of a flush appearance to the piece and is again not in any way going to be able to make contact with the track. This procedure was done to all 4 of the bump stops on the model. In addition to the bump stops, the pin deflector was also ground down for the same reason as the bump stops were. With all these locations ground down, the model's track will have no reason to make contact with any of these pieces, and the track now runs a lot smoother. If we notice that all of the pieces are, since they were ground down, are now exposed with their bare metal. These pieces will all be painted over once the model enters its painting procedure. Also, as of note, when the model begins to enter its painting phase, the tracks will be temporarily removed so I get access to all of the areas of the model. To adjust the idlers on the Armortek model, it's just like that on the real German tank. To adjust the tension is controlled via a hex bolt that is in this location over here. This location here has a armored cover cap, which is also found on the real vehicle. And just like the real vehicle, to get access to the actual Allen screw, you have to remove the armored cover cap. After the armored cover cap is removed, the tension is adjusted via this Allen wrench. You just stick it in to the hole, and you could then adjust the tension of the screw until you have it just perfect. Before we continue with the video, let's take a look at some of the footage from the model's second test drive. As we can see from the model's second test drive, that the model performed a lot better and that the rear wheel problem was pretty much eliminated. The only hiccups that we had were from interruptions between radio frequencies. This is because the model's antenna is not really hooked up yet, and when the model's all buttoned up like you see here, radio waves have trouble getting to the receiver. This will all be fixed once the radio antenna is properly extended out through the model's actual radio the radio antenna base that we have on the rear deck of the vehicle. And here goes the model's interior with the modified machinery layout. We will go over the interior layout in this video. For the main power supply is mounted here into the front. The power supply switch is this little red button here and is positioned to be directly underneath the driver's hatch. So when you want to operate the model, you simply lift up the driver's hatch and turn on the model. The box itself is affixed to the mount via a Velcro pad. The Velcro pad is nice and strong and keeps the unit nice and sturdy. However, it's also removable in case I need to get access or if any access is needed after the model is built. The panel itself is affixed to a piece of Lexan, which is mounted to two horizontal aluminum billets. The system itself is very sturdy and is also nice and lightweight. This apparatus that we have here, is the model's recharge system. Just like with the on and off switch, the recharge system is positioned under the radio operator's hatch. Whenever you need to recharge the model, you simply lift up the radio operator's hatch and insert the two jugs, both the positive and negative jacks, to these mounts here, hit the switch, and the model will now be charging. Once you're done charging, simply turn off the charge, and remove the wires. Because the model has the torsion bar suspension, fitting the electronics could be a little bit tricky. The original builder mounted the two 4QD speed controllers to the top sponsons here of the model. Problem with that is that even though the speed controllers are out of the way, you cannot be able to fit the on and off switch underneath the driver's hatch. And for a model this big, you want to have the switch at an accessible location. Something that the other model maker didn't keep in mind. What I did was I moved the 4QD speed controllers to the bottom to the model's hull floor. However, because of the torsion bars, I wasn't able to fit the speed controllers or any of the other equipment directly to the floor. This is a common issue with all these German tanks with the torsion bar suspension, as you have the torsion bars running underneath. To fit the machinery to the model's hull, I simply made a floor out of Lexan plastic. Like I mentioned for the on and off box, the Lexan plastic is nice and lightweight and is still very strong. To fit the plate, I needed to add risers to the model's floorboards. The risers themselves are just simple columns made out of PVC tubes that are filled in with casting resin. The resin tube column was then machined on a lathe and drilled out to very specific specs, so it's all nice and uniform. After the pieces were all cut to shape, holes were drilled into the hull, bolts were fitted through, and are retained via these nylock nuts over here. I went ahead and used these nylock nuts because since this model will be running and will be susceptible to some vibrations, you don't want these fasteners getting loose. And the nylon bolt over here will prevent that from happening. After the floorboard was affixed, the two speed controllers are actually fitted to the floorboards via fasteners and are now velcroed on. The floorboards themselves will continue all throughout the length of the front of the model here. I did that to supply ample space for any type of servo tray or any type of other machinery that I might have throughout the rest of the build. Fitted to this side of the hull, we can see here the model's radio receiver was fitted. The receiver is also mounted on via Velcro, so in case I need to move it, I can position it anywhere else in the hull. The model's antenna will be connected to the model's actual radio antenna once the build progresses further. The way the electronics break down are as follows. You have the two batteries. These two 12-volt batteries are hooked in series circuit, which give you the 24 volts needed to power the model. The 24 volts run through the wires here and enter into the power control box. From this power control box, it is then subdivided to all of the necessary functions. Within these two covered wires, these two jacketed wires here, are the wirings for the model's 4QD speed controllers, which then go into the motors, as well as go into this electronic box here, which takes the output from the motors and has it controlled via the radio control equipment. For the elevation and the rotation, those are facilitated by these electronicized little speed controllers here. This speed controller here controls the model's target rotation. This one here controls the model's gun elevation, and this one here would have controlled the model's gun elevation, or the blank firing system. This whole system here was both wired and Velcroed together by the previous builder. The wires themselves needed to be revised a bit as he had a few mistakes in the wiring diagram, and the model would not have worked if I did not check that. This jack that we see here, this would have been for the Armortek supplied smoke system, as well as possibly even the sound card, which was offered at that time. This jack here plugs into the subloom box, and this box here pretty much powers all of the turreted functions, which include both the turret rotation as well as the gun elevation. Another jack that we also have here on this power box is the power for the model's RC receiver. The Armortek model has the RC receiver with its own built-in power supply, and so the use of an external battery is not needed to power the Armortek model. In addition to getting work done on the model's machinery interior layout, I was also able to configure and test both the turret turner motor as well as the gun elevation motor and restrictor system that we have here. Once these pieces are installed, the interior is going to be a lot more clean with all of the loose wiring that you see. For the turret turner, the Armortek kit supplies you with a very powerful 12-volt geared DC motor. The motor is pretty much all ready to go. It has a very rugged pinion gear over here, as well as a very sturdy aluminum bracket to mount it to the model's upper hull. It's all fastener construction and we'll get the job done. The motor is also pre-wired and is again a simple plug-in installation. Once the top deck is being worked on, the motor will be fitted to the top deck, and I will go into more of that once I am up to that step. For the sub-loom, we have here the main socket, which connects to the main power supply socket umbilical right over here. Then it's all pretty much simple snap type jacks that we can see here. The jacks are designed so that you can't invert the two, so that the wiring is pretty much plug and play installation. These restrictor switches are just held on with simple plug-in jacks. It can get a little bit confusing, however, if you follow the instructions and follow it carefully, you should have no problem with the wiring. This jack that we have here is left exposed, and this jack here would be for if the model had the blank firing system. Back when this kit was developed in 2006-2007, Armortek had a blank firing revolver 12-gauge system, which would fire blanks only, and that would plug in to this little jack here. Since then, Armortek has phased out the blank firing system completely and is no longer an accessory or an option that can be mounted to their newer generation kits. All of the model's kit functions that we see here are connected to the turret via this long umbilical cord, also known as the sub-loom. Sub-loom, it's all plug-in installation and gives you a nice long cable here, which will be spooled in this type of fashion here once the turret is installed. The long cable facilitates a lot of flexibility, and especially which is needed for something like a turret, which will be turning in either direction. We will now test the systems now. I will first turn on the radio. It's always good on these Armortek tanks to turn the radio on first, because if you turn the tank on first, the tank might be able to drive on itself, and when you have a model this heavy, that's not a good thing. So first we turn on the radio, and then we turn on the tank's power supply. The model is now on. To turn the turret, it's this toggle over here. And for the gun's elevation, we use this toggle. Now what's very unique about the Armortek system is they have an inhibitor system here to prevent the gun from overstretching in either direction, both up and down. The way it works is that once the system is installed, the barrel will be able to hit these limit switches. Once they hit the limit switches, the motor will shut off in that particular direction, which will only allow the gun to be moved in the opposite direction. And that would be as follows. See, now the motor shut off. If I go the other direction, the motor will still activate. Same thing with the opposite way. Once the system gets installed, everything will be checked thoroughly, but so far everything looks like to be green lighted. To turn the model off, it's just like turning it on but in reverse. Instead of turning off the radio, first we turn off the model, and then once the model is safely turned off, we can then turn off the radio. The way these Armortek kits are purchased and the way they're divided is that you purchase the model itself, which is just basically the shell. It's a static model. It's the body, the turret, the tracks, and the basic detailing. To get the model running, those pieces and components are offered in what's called option packs. The option packs divvy up all the functions and details. For option pack 1, which I believe is the basic system, you receive the two large main drive motors, the turret turner, as well as the gun elevation motor system. Also included with the same option pack is the power control relay box, as well as the speed controllers for both the main drive, as well as the gun elevation and rotation system that we have. The only thing not included are the batteries, as well as the model's radio control equipment, i.e. the receiver and the radio. That's for the basic options. For some of the other special features, like the sound system, smoke generator system, even the new recoil system, and as well as the older blank firing system, those options were offered have to be ordered extra and are not included with the main drive system. For the machine gun ball itself, the machine gun ball is not the Armortek kit original. The Armortek kit original piece was all CNC'd out of aluminum. This piece here is a replacement aftermarket production piece, and it is all made out of cast resin. The ball is more superior to the original Armortek offering in that it has the bullet splash rails on the interior portion here of the machine gun ball mount, and it also features the casting texture built in. While I was working on the lower chassis of the model, the machine gun ball popped off. The previous builder who built the model did not secure the machine gun ball properly to the hull. Rather than using fasteners to mount the ball mount to the hull, he used adhesives instead. The adhesives ripped right out, and because of that, I had to first clean out the well from all of the glue and adhesives that were clunked on there to make sure that the ball fits nice and secure and flush to the upper hull. Rather than using any adhesives, I used metal fasteners instead. The fasteners give a lot more strong of a bond, and also, which is needed because since the machine gun has to pivot, there are some added stresses to the ball and the hull that the adhesives alone would not have been able to withhold. Positioned on the front portion here of the model, we have a servo that controls the left and right movement of the model's MG34 machine gun. The servo is hooked up to the radio receiver and is fully functional. For the machine gun, the actual channel itself, I use the knob here on the radio. The advantage about using this channel for the machine gun ball is that you could leave it pointing in a certain direction if you desire. Here we can see with the top deck temporarily mounted how to get access to the model's recharge system as well as the main power. As I mentioned in an earlier scene, the system is designed to have the most amount of accessibility to these portions of the model via the front hatches. To demonstrate how to charge the batteries, I temporarily fitted the top deck to the model. And to charge the batteries, I'll be using this 24-volt DC charger. Charger itself will charge both batteries at the same time. On the ends, we have the two jacks mounted to the charger, and these jacks will simply plug into the system here and charge the batteries. Again, to charge the batteries, I simply plug in the color corresponding jacks to their locations and hit the switch. Before I do, the green light here shows that nothing is hooked up or that the batteries are charged. Once I hit the switch here, this light will turn to an amber color light, which means recharging. Just like that. Now the model is recharging. Just to halt the recharge, or if the tank is fully recharged, I hit the switch again and unplug the jacks. Now I would just simply close the hatch and turn on the model and start operating the model. Also, as we can notice, the model's gun and muzzle brake were remounted. As I mentioned in an earlier video, the previous builder of the model kept the gun and muzzle brake, and because of which a new one needed to be found. Luckily, Armortek has fantastic customer service, and I was able to obtain an official Armortek muzzle and gun brake direct from the factory with no problems at all. Special thanks to Mark and Jill for the great customer service that they offer. The barrel and muzzle itself are all threaded on and just simply screw-on assembly. I'll have more information on the gun and muzzle brake, as well as some mods to make to the muzzle brake once the build progresses. And that concludes this project update video for this early production 1/6 scale Armortek Panther Ausf.G. If you like this video, stop by and like us on Facebook. And also, don't forget to check out eastcoastarmory.com for more 1/6 scale tank builds, as well as other 1/6 scale detail components. Thank you.